In this video, we are going to find all integers x and y such that x to the power 4 plus y equals x cubed plus y squared. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first step would be to rearrange the terms on both sides so that one side contains all terms of powers of x and the other side contains powers of y. So by rearranging, we have x to the power 4 minus x cubed equals y squared minus y. Now my approach is to kind of do something like completing the square, because I notice that if I add a constant on the right side, then it will surely be guaranteed to be a perfect square. And to be precise, I'm going to multiply both sides by 4 first. And that equals 4y squared minus 4y. Originally, I can add a quarter at the end of the right, so then the right side will be a perfect square. It's y minus 1/2 all squared. But now, after multiplying both sides by 4, I can add both sides by 1. So then the right side becomes 2y minus 1 all squared. While for the left, we have 4x to the power 4 minus 4x cubed plus 1. But notice that for the expression at the left, this quartic expression, for most values of x is actually between some consecutive perfect squares. Indeed, notice that for 4x to the power 4 minus 4x cubed is actually very close to something like 2x squared. Maybe I can write it here. 2x squared minus x all squared, and we have 4x to the power 4 minus 4x cubed plus x squared. Now for this perfect squared, when x is at least 2, then it is always larger than the one in green, 4x to the power 4 minus 4x cubed plus 1. On the other hand, if it's the previous perfect squared, 2x squared minus x minus 1 all squared, then if I expand it, I will have 4x to the power 4 plus x squared plus 1, adding all the individual squares, and then minus 2 times the mutual product, minus 4x cubed minus 4x squared, and finally plus 2x. So rearranging, again we have an expression starting with 4x to the power 4 minus 4x cubed, and in between we have minus 3x squared plus 2x plus 1. So we can see that there is an extra minus 3x squared plus 2x over here, and we can claim that when x is larger than or equal to 2 or x is less than or equal to minus 2, of course, it's also okay to write in this way: absolute value of x is larger than or equal to 2. Then, on one hand, we have the expression above to be less than (2x squared minus x all squared), and on the other hand, I can say it's also strictly larger than the previous perfect squared. Now for this part, we need some extra steps to prove it. So the right side is true for just using the first sentence. At the same time, if we want this to be less than 0, then we need to take out x like this, and we have x times 3x minus 2 to be larger than 0. And as long as x is positive, sorry, not positive, but negative, or x is larger than 2 over 3, then this range will hold. Therefore, if x is at least 2 or even smaller than or equal to minus 2, then it will definitely fall within the range we've solved just now. And so that means this is less than 0. And so we have also proved the second part of the inequality. The one in the proof in the inside the red box is just for the inequality at the above, again in the red box. So we've finished the proof. Now from the claim, we can say that we can say that 2x squared minus x minus 1 all squared is always less than 2y minus 1 all squared, and that's less than the next perfect squared for all x with absolute value larger than or equal to 2. So that means there should be no solution when x is within this range. So we can just ignore all these values and just focus on the rest, which means we only consider when x equals minus 1, 0, or 1. Then our question becomes much simpler. When x equals minus 1, our equation becomes minus 1 all to the power 4, which is 1 plus y, and that equals x cubed plus y squared, so that's minus 1 plus y squared. So y squared minus y minus 2 equals 0. And we can factorize and solve it. We have y minus equal to minus 1 or 2. When x equals 0, we can just ignore all the x, and we have y equals y squared. So y equals 0 or 1. And for x equals 1, again, because x to the power 4 and x cubed is the same when x equals 1, so we remove them, and again we have y equals 0 or 1. So altogether we have the following solutions. When x is minus 1, we have these two solutions. For 0, we have these two solutions, and for x equals 1, we have these solutions. And we've actually solved them out, so we've actually checked them already. So these are all the valid solutions and our final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.